All right, hi chemistry class. This is the day 34 assignment. It'll cover slides 1 through 9, and I'm just going to go through them with you here. So what is chemistry? So everything in the universe can be divided into two things. Matter is stuff. It's things you can touch, hold. It basically has mass. Energy is what causes matter to move or change. If you throw a ball, it has energy in it while it's moving through the air. When it's sitting still, it doesn't have energy. The other thing you could do is light a match to a piece of wood, and the wood may not be moving, but it's burning, and that is causing the wood to change. It's causing the matter to change in some way. So it causes matter to either move or change. That's what energy does. So it's physics that's interested in different forms of energy, and by contrast, it's chemistry that's interested in matter and what things are made of. Energy does come into play in chemistry because we are changing things, so we do need energy to do that, but it's not the primary focus of chemistry. Alright, so what is electrical force? So the electromagnetic force is a force of nature, just as gravity is a force of nature, and we've talked about gravity. You've talked about gravity actually in physics. The key point to remember about electrical force is that positive attracts negative, and negative attracts positive. Also, positive repels, that is, pushes away positive, and negative repels negative. And this very simple concept, this very simple relationship is seen every day for the rest of this class. Is this idea of positive and negative and their relation to each other. So what is an element? So an element is pure matter that cannot be divided into simpler substances. There are 90 naturally occurring elements, about 90. The largest naturally occurring element is uranium, which is number 92 on the periodic table. There's a few others that are kind of iffy as to whether they're natural or not. Some of them just fall apart very quickly and aren't really considered to be natural elements. But there's about 90 of them, and then there's another 20 or so, it's actually more than that now, that have been created by scientists in labs. So all matter in the universe is made of just these 90 elements. You can think of them like letters in the alphabet. There's 26 letters in the alphabet, and they can be used to make millions and millions of words. So just as the 26 letters of the English language can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances and compounds. A compound is a substance containing two or more elements, and there are up to 50 million chemical substances, and that number varies widely, that 50 million number, depending on what source you go to. Alright, so what is the periodic table? Well, the periodic table is a list of all the elements in the universe. The periodic table is the centerpiece for the study of chemistry. So what is truly amazing about the periodic table is that every substance in the universe, every pure substance, is on that little table right there. There's nothing that's been left off. Alright, so what is the periodic table? So Dmitri Mendeleev is credited with creating the periodic table. And he did much of his work, interestingly, by laying out cards while he was riding trains around Russia and figuring out the relation between different elements and where one should fit in relation to all of the others. So how was atomic theory developed? Well, in about 400 BC, a Greek named Democritus developed the idea that there was a smallest piece of matter, and that piece of matter could not be further divided. The Greek word atomos means indivisible, which means cannot be divided, and the smallest piece of an element is called an atom. There were other philosophers who believed that no, you could at least theoretically keep cutting a piece of an element forever, just infinitely, that there was no smallest piece. Turns out Democritus was right about that, although he had no scientific way to prove it. Now, the atomic theory came about in the early 1800s with a man named John Dalton. So in about 1800, English chemist John Dalton developed a formal scientific theory of atoms. First is, all elements are comprised of indivisible atoms. Well, there's slight modification on that. We know now that you can split an atom. That's how nuclear power is obtained. But for the most part, that is a correct statement, that atoms are indivisible. We don't break up atoms, generally speaking, in chemistry. Number 2, atoms of the same element are identical, and that is somewhat true. Atoms of one element are different from those of another. We're going to learn about isotopes and ions, and those are where atoms of the same element can be a little bit different, but generally speaking, that is a true statement as well. Number 3, atoms of different elements can combine in whole number ratios to form compounds. And a compound is a combination of 2 or more elements. And that's a true statement. For example, we all know that the chemical formula for water is H2O. There's no such thing as H1.5O or H1.7O. It has to be a whole number, 1, 2, 3, 4. So that is a correct statement. Atoms of different elements combine in whole number ratios. Finally, number 4, chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. Again, that's essentially true. When we split atom, say uranium, for example, we can create plutonium. That's a different element, but that's very, very rare, and that's not the general thrust of chemistry. But he is correct, absolutely, that the reactions are when atoms join, separate, or rearrange. He didn't know how they did this. He just theorized that that's what was going on. Okay, so what is an atom? An atom is the smallest piece of an element that there is. So if you cut an atom of gold or iron in half, you will no longer have gold or iron. An atom consists of 3 components: the protons, which are positively charged, neutrons, no charge, electrons, negatively charged. The only thing to understand about positive, negative, it just means that they're oppositely charged. It doesn't mean that one is better than the other. It's just they have opposite charges that go together, and it will attract each other. And here is a very simple diagram of an atom. It's a diagram that's good enough for most of the study of chemistry that we're going to do in this class, almost all of it. So what do we have? What does it look like? This is a helium atom, by the way, because it has 2 protons. It's number 2 on the periodic table. So first of all, let's start with the nucleus. The nucleus is the center of the atom. There's not a pouch. That green circle is not really a pouch like you would have in biology for the nucleus of a cell. It just simply represents the center of the atom. Inside the nucleus, you have protons, positively charged elements, positively charged particles, and neutrons, which are neutral. Now you might think, well, what do the neutrons do if they're neutral? They don't attract or repel. But those particles have something called the strong nuclear force, and that's what holds the protons together, because 2 positively charged protons should repel each other and just fly apart, but they don't. They're held together by something called the strong nuclear force. That's what holds the nucleus of an atom together. And the neutrons, even though they don't have any charge, they contribute that strong nuclear force. You can think of those like hooks between the protons and the neutrons, and between the protons and the protons. The protons have strong nuclear force between each other as well. So those are the 2 particles inside. The protons and the neutrons, by the way, have approximately the same mass, and we call that 1 atomic mass unit. We'll talk about that very shortly. Electrons fly around the outside. This is not the scale, this diagram. They're not the same size as protons and neutrons. They're only about 1/2000th the size of protons and neutrons. They're really tiny. You've got to figure that if they're flying around the outside of the atom, that they got to be really small and light, and they are compared to protons and neutrons. They are negatively charged. So the reason the electrons don't fly off into space is because they're attracted in to the protons, to the positive charges. Then you also have an orbital, and an orbital, it represents an energy level. These electrons can't just fly anywhere. They have to fly in a certain energy level in relation to the nucleus of the atom. And so we represent that by a simple circle, but they do not simply go around and around in a circle like that. They kind of buzz around like flies in a room, but they have to do it at certain levels or distances from the nucleus. So what's a valence orbital? A valence orbital is the outer orbital of an atom. So in this case, the valence orbital, there's only one orbital, so the valence orbital would be the first orbital. If you get to the second row of the periodic table, it has 2 orbitals, and the second one would be the valence orbital. The word valence just means outside. That's all you have to remember. So it's the outer orbital of an atom. because helium has only one orbital, this is the valence orbital. It is the valence electrons that form chemical bonds, and chemical bonds are what's at the heart of creating chemical reactions and new substances. So those happen with the valence electrons, and that's why those are the really important electrons in a chemical reaction. All right, so this takes care of this first day, Monday, April the 13th. It's the first day lecture. Just answer the questions that are on the assignment sheet. And then you have another video to watch and some questions, I believe, to go with that, or write a paragraph. It'll be one of those two things each day. So we'll talk to you on the next video tomorrow. Have a good day.